I'm going to read from The Universe, an introduction by the Smithsonian. So we're going to read just a couple of pages of this article, starting with some questions. First things first, what is the universe? Speaking generally, universe means everything, all we see and cannot see. When astronomers speak of the universe, they usually mean the observable universe, what technology has enabled us to see, or what physical laws will permit us to see as technology advances. How big is the observable universe? Astronomers usually measure the far reaches of space in light years. A light year is the distance that light travels in 1 year, about 6 trillion miles. Our farthest views of space have come to us from the Hubble Space Telescope, launched by NASA in 1990. Hubble revealed galaxies more than 10 billion light years away, or 60 billion trillion miles. Light in the form of radio waves has come to us from another few billion light years beyond those galaxies. What is a galaxy? A galaxy is an assembly of stars and related matter and gas, all held together by mutual gravity. We might think of a galaxy as a super megalopolis of stars. A more common analogy is that a galaxy is a vast island in space, separated from the others by trillions of light years. So we have lots of galaxies, which are these balls of matter and gas all held together. Little islands of these galaxies separated by space. Less than a century ago, we could speak of the galaxy, our own Milky Way, without even pluralizing the word, meaning we spoke of the galaxy, not galaxies. The Milky Way got its name from its appearance to the naked eye. The galaxy has a disc shape. We are within the disc. Overhead, we get a sideways view. We see the disk as a band of so many stars that they appear as a creaminess of light. Scientists early in the 20th century, Albert Einstein among them, believed that these stars, this galaxy, made up the whole of the universe. Beyond the galaxy was a void, was nothing. So we have this disk, and we are in that disk, and we are looking, when we look up out of Earth, we are looking up into the sky, but we are looking into that disk, and we see all the other dust and gas and stars that are in that, and that's that cloudiness of the Milky Way. In 1917, the Wilson Observatory in Pasadena, California, erected a 100-inch wide telescope, the largest in the world. Missouri-born astronomer Edwin Hubble, namesake of the Hubble Space Telescope, went to Pasadena to study a nebula, a fuzzy patch of gas and dust. Using the telescope, he discovered that the fuzz was far more distant than anyone imagined. It contained not only gas and dust, but also stars. What was considered a small part of our galaxy and called the Andromeda Nebula became the Andromeda Galaxy. It was another island altogether, millions of light years from ours. It is now estimated that there are more than 170 billion galaxies in the observable universe, each containing tens or hundreds of billions of stars. So what is a star? We can turn to rock and roll for a concise definition of a star. A star is a great ball of fire. It is necessarily a ball. Like a planet, it forms from a spinning cloud of dust and gas that has collapsed under its own gravity, pulling inward equally in all directions. And it is necessarily great. Unlike the smaller planets, its sheer mass exerts a pressure that sets off a nuclear fire, which in most cases burns for billions of years. The closest star, our own star, is the sun. As stars go, ours is quite average. It's middle-aged, it's of medium build, and it's moderately bright. The difference between the sun's blaze in our sky and the cool twinkle of the other stars is the difference of distance. If our galaxy is a megalopolis, our star is the core city of a metropolitan area, with its solar system as its suburbs. Earth, the third planet from its star, is the toniest of inner suburbs, enjoying the heat and light of the star, but not too much of it. What is a planet? As with galaxy, the meaning of planet has changed considerably, and even more recently. For decades, a planet could be safely defined as any of 9 bodies that revolve around the sun. Outward from the sun, they are Mercury, Venus, Earth, and Mars, the terrestrial or Earth-like planets. Jupiter, Saturn, Uranus, and Neptune are the gas giants. And then there's Pluto. The American astronomer Clyde Tombaugh discovered the icy misfit Pluto in 1930 and thus made a possible catchy first-letter memory aid. My very educated mother just served us 9 pizzas, which is the mnemonic device that I learned as a child. There's our 9 planets. In 2006, those who came to know the planets by thinking of 9 pizzas were stunned to learn that Pluto was gone. That is, members of the International Astronomical Union had voted to strip Pluto of its status as a planet. So Pluto itself wasn't gone. They just demoted it to a dwarf planet. Was the result of the IAU's effort to give planet its first official definition. According to the definition, a planet must be an orbiting body large enough to become round by the force of its own gravity and large enough to dominate the neighborhood of its orbit, which means that anything near it would get pulled into it and impact it. While certainly round, tiny Pluto is hardly dominant. If it were set down on the surface of Earth, it would barely cover India. That being large enough means it clears its belt, it clears its revolution around the sun of other bodies, and Pluto's not big enough to have brought in anything else near it. The loss of Pluto as a planet had been offset by the discovery of planets outside of our solar system. Since the time of Galileo, when the sun was found to be a star, astronomers have thought it likely that other stars are orbited by planets too. The discovery of the first exoplanet came in 1995, and more than 400 have been spotted since. Most are gas giants and unlikely to support life. This does not mean that these are the most common kind of planet, only that they are the ones least difficult to find. They're gas giants, so they have a really big gravitational pull on their neighboring star. Planet hunters are focused on the possibility that some of them have moons that are more Earth-like than the planet itself. So what is a moon? A moon is a natural satellite of a planet. Our moon is one of at least 90 in our solar system, almost all of which are beyond the realm of the terrestrial planets. Mars has 2 small moons. Mercury and Venus have none. Our moon is unusually large, about 1/4 the size of Earth. While it is in thrall to our gravitational pull, it is large enough to pull back. The moon's gravity slows our rotation and creates our ocean tides. The surface of the moon is, of course, the farthest out in space that we have stepped. Among the many firsts of the Apollo missions is that it was our first hands-on experience with the finite speed of light. The average distance to the moon is 240,000 miles. Light travels at 186,000 miles per second. Moonlight then takes a little more than 1 second to reach us. This slight time lag was observed in the transmission of images from the astronauts to ground control. Light year measurement allows us to pack vast numbers into manageable units. It also helps us to think in terms of age. As the moon landing showed, nothing in space comes to us live. It means that we couldn't see the moon images as fast as they actually happened, right? There was a little bit of time delay. So when we look out into space, we look back in time. The farther we look, the farther back we see. We see the Hubble Space Telescope galaxies 10 to 12 billion light years away. So it means it has taken 10 to 12 billion light years for that light to come to Earth, which means that when it hits us, it's 10 to 12 billion years ago. That is how long the light has taken to reach us. We see those galaxies in an infant state at a time near the beginning of the observable universe, which has been dated at about 14 billion years ago. So what's amazing to me is when we see something in a galaxy that's far away from us, it has taken 10 to 12 billion years for that light to reach us, which means that that galaxy or that star has been continuing to do its galaxy or star things for 10 to 12 billion years, and we won't even know about it. Like, it's happening right now, but we won't see it until that light can get to us in another 10 to 12 billion years. It's just mind-blowing how far away things are and how long it really takes light to travel to us, even though we see light so instantaneously. All right, that's a little brief introduction to some of these key terms as we look at the universe.